So today we will learn to calculate the total amount of R.C.C quantity and reinforcement quantity of an R.C.C slab. Okay, suppose there is an R.C.C slab like this. Suppose this is a one-way slab. Suppose it's a one-way slab of clear span. Suppose this is a clear span of 3 meter by 6 meter. Okay, so this is a one-way slab. So the main reinforcement given are like, suppose 10 mm diameter at the rate of 100 millimeter center to center. This is the main reinforcement given. Okay, so how the main reinforcement is laid, that you need to know. The main reinforcement is always laid along the shorter span. You should remember this thing, that the main reinforcement will always be laid in the shorter span. And how it is laid, I will tell you. First of all, this is the shorter span. So along this shorter span only the main reinforcement will be laid, and the main reinforcement given is here 10 millimeter diameter bars at the rate of 100 millimeter center to center. So let us see how the main reinforcement is laid. Okay, so first of all, a reinforcement will come from this direction. It will be cranked at L/4 length, then it will go on like this. Okay, now another reinforcement will come from reinforcement bar will come from this side. It will be cranked like this. This is called cranked or bent up, and it will go on like this. Now why this crank is given? This crank is given to counteract the negative bending moment which is produced at the ends, on the top sides, and at the bottom in the mid portion. Okay, so next another bar will come like this. It will be cranked and it will go like this. So from this direction another bar will come like this. It will be cranked and it will go like this. So this is how the main reinforcement is laid. Now as you can see, what is the diameter of these bars? The diameter of these bars are 10 millimeter. It is given. And what is the spacing between the bars? The spacing between the bars is given in the question as 100 millimeter. Okay, so after this main reinforcement is laid, we can go for, so along this direction we have placed the bars, along the shorter direction we have placed the bars, and these are called main reinforcement. So after the laying of main reinforcement is complete, we'll go for laying of the bars along the longer direction. Okay, now let us move on to that. Now you know how the main reinforcement is laid. Now let us move to the reinforcement which is going to be provided along the longer direction. And the reinforcement which will be provided in the longer direction is called distribution reinforcement. And distribution reinforcement is provided at 10 millimeter diameter bars at the rate of, suppose, 120 millimeter center to center. Now these bars will be laid like this. What are the diameter of these bars? 10 mm. Yeah. What is the spacing between the bars? 120. Okay, so it will go like this. So first of all, main reinforcement was laid in this direction, like this, and above the main reinforcement we have laid the distribution bars like this. Okay, now these distribution bars are laid at the bottom. Now at the top also, this cranktop for this cranktop portion, for this cranktop portion, in this cranktop portion we provide some distribution bars only for this cranktop portion. Suppose 3 numbers of distribution bars are provided at the cranktop portion. So if we look at the section, if we cut this in half and look at it, look at the slab from this direction, what the section is going to look like. Let us try to draw the section. Let us place the reinforcement first. Cranked up, another crank, crank, crank. Okay, so the main reinforcement is laid. Now above this above this main reinforcement, the distribution reinforcement will be laid. Now these distribution reinforcements are laid at the bottom. So the top reinforcement on this cranked up portion only, we have placed 3 bars on either side. So this is how our reinforcement is complete. Now if you look at this from this side, then how the section will look like? I think this will look like this. Cranked up portion. This is cranked up portion. Another cranked up portion. Because if we look at this slab from this side, we'll see both the cranks from this side and from this side also. Okay. These are the distribution bars. So this bar and this bar are main reinforcement because they are laid in the shorter direction. And which bars are laid in the longer direction? These are these head, circular heads that we are seeing. So these are distribution. Okay. Now as I said, some distribution bars will be laid on the top also in the cranked up portion. Suppose on both the sides we have placed 3 distribution bars for the cranked up portion, for the bent up portion, for only this portion, to support this portion, because this portion is cranked up. So if there is any load is placed here, there are chances of failure. So to support this bent up portion, we have placed 3 distribution bars. So these are also distribution bars, but they are called top distribution because they are provided on the top. These are top distribution. Okay, so this is how the section will look like. Now let us assume the thickness of the slab to be 150 millimeter. Okay, now we will try to calculate the amount of R.C.C quantity as well as reinforcement quantity for this slab. Now suppose this is the if this is the section of the slab is inserted within the supports like this. Suppose in this direction, what is the span? This is 3 meter as given in the question. Suppose the slab has a bearing of 15 centimeter on either side. That means it is 15 centimeter inserted into the supports. So what will be the total span? This is 3.3. Clear span is 3. Total span is, or effective span is 3.3, because it is inserted by an amount of 15 centimeter. This has a bearing of 15 centimeter on both the sides. Just like the other case also, the clear span is 6, but the effective or total span will be 6.3, because this will be 15 centimeter bearing, and there will be 15 centimeter bearing on both the sides, isn't it? So first of all, let us calculate the amount of R.C.C quantity. What is the length? Total length will be 6.3, breadth will be 3.3, and what is the thickness? Thickness of the slab is assumed to be 15 centimeter or 0.15 meter. So this much of meter cube. This is not length. So this much of meter cube is the total R.C.C quantity. This is the total R.C.C. Whatever quantities you get, this is the total quantity of R.C.C. This is how we are going to find out the total R.C.C quantity. Now we will try to calculate the amount of reinforcement which is required for this slab. Now this is our slab. Isn't it? This is our slab. Now main reinforcement is provided in this direction, like this. So now let us calculate the amount of main reinforcement first. Let us calculate the amount of main reinforcement first. Okay. So first of all, we need to find out how many numbers of bars are provided. How many numbers of bars. Be careful, we are talking about main reinforcement. Main reinforcement. Okay. So how many numbers of bars are provided? Now what is the spacing of this main reinforcement? It is given as 100. What is this total length on this side? This is given as 6.3, isn't it? Now we need to find out the number of bars provided along the shorter span, which is the main reinforcement. Okay. Now what is this length along which the main reinforcement is provided? Along which length the main reinforcement is provided? Along this length, 6.3, isn't it? But the length we will consider is not 6.3, because we will not provide reinforcement up to this point. Up to the extreme point we will not provide reinforcement. There will always be a gap on this side, on this side, on this side, and on this side, and that gap is called clear cover. This clear cover will always be there in beams, columns, slabs, foundation. In any kind of R.C.C member, this clear cover will be there, and this clear cover is assumed to be 40 millimeter or 4 centimeter for slabs, and we are assuming this clear cover to be 40 millimeter. So let me make the things clear. So if this is the slab, suppose this total span is 3.3 and this total span is 6.3. In this whole length, in this whole dimension, the reinforcement will not be provided. There will be a gap from this side of 40 millimeter, 40 millimeter, 40 millimeter, 40 millimeter, 40 millimeter. Gap will be kept from all the sides, and in the remaining portion only, in this remaining portion only, we will provide the reinforcement. There will be a gap on all the sides, and this gap is called clear cover. So if this is 40 millimeter or 4 centimeter and this is 4 centimeter, then what is the length along this direction where the reinforcement will be provided? The length will be 6.3 minus 4 centimeter, that means 0.04, minus again 4 centimeter, 0.04. Okay, so along this direction, so this becomes 6.22. So this becomes 6.22 along which, over which the main reinforcement will be provided. So over this length of 6.22 the main reinforcement will be provided. Okay, so this length is 6.22, and along this 6.22 length only we will provide our reinforcements like this. Clear? So how many numbers of bars will be there at the rate of 100, 100, 100? So number of bars is equal to 6.22 divided by 100, that is 0.1 plus 1. Total length divided by spacing plus 1. Now why this plus 1? Because this is the number of spacing only. Suppose this is a slab and we are providing reinforcement like this. So how many spacing are there? 1, 2, 3. There are 3 spacings. But how many reinforcement bars are there? 1, 2, 3, 4. So always it is, number of bars is always number of spacing plus 1 in one direction. In the other direction again, number of total length divided by number of spacing plus 1. Okay, so this becomes 63.2. We will adopt 63 numbers of bars. So number becomes 63 numbers for main reinforcement, isn't it? Now we need to find out the length of one bar. The length of one bar. So this is our slab. This was 6.22. How much is this one? This whole length was 3.3, I think. So this will be 3.3 minus 0.04 minus 0.04, just like this case. So this becomes 3.22. So length of one bar is 3.22. So, but the if we look at it from the top, the length becomes 3.22, but it is more than 3.22 because it is cranked like this. So, if we look at the bar, how it is provided? It is provided like this, cranked. So this length is 3.22, that is okay. This length is 3.22, that is okay. But what about this depth? This depth is taken as 4 centimeter. No, sorry, sir. This depth it will be taken as yes, 4 centimeter. This depth is taken as 4 centimeter. This depth. So 3.22 plus 0.04 plus there will be hooks provided like this on both the sides for better grip, for better bonding between reinforcement and concrete. So the length for one hook is 9 times diameter of the rod. So this side 9 times diameter of the rod, this side 9 times diameter of the rod. So total 18 times diameter of the rod. 18 times diameter of the rod. And here in this case the diameter is assumed to be, diameter of the rod is assumed to be 10 millimeter. That means 0.01 meter. So D is in this case 0.01 meter. So this is the total length of one bar, and this comes to be, let me check, this comes to be 3.44 meter. So length of one bar is 3.44 meter. Total number of bar is 63. So now we can calculate the total amount of main reinforcement. So total number of bar is 63. Length of one bar is 3.44. So total length is 63 multiplied by 3.44. This comes to be 216.72 meters. And the reinforcement which is used as 10 mm diameter. Okay. Now we need to convert this total length of reinforcement, of main reinforcement, into weight. So we will have to multiply this total length by unit weight of 10 mm dia bar. Okay, 10 mm dia bar unit weight is 0.62 kg per meter. You will have to remember this. So total weight becomes 216.72 meter into 0.62 kg per meter. Meter gets cancelled, whatever remains is kg. So let us find out what is the total amount of kg. This becomes 134.36 kg. So this is the total amount of main reinforcement. Okay, now we'll try to calculate the total amount of distribution reinforcement. Okay, for that let us come back to the slab once again. Distribution reinforcement is provided like this. Spacing was, I think, 120, isn't it? 120. And this length was, I think, along with the length which the main reinforcement was provided was, I think, 3.22. So the number of bars will be 3.22 meter divided by 120 millimeter, that means 0.12 meter plus 1, because this is the number of spacing, plus 1 if you do, then this is the total number of rods. So let us find out what is this value. The value becomes 27.83. So let us take 28. So number of bars is 28. Now we need to find out the length of one distribution bar. So this was, I think, 6.22. So distribution bar is provided like this. There are two hooks. One hook is 9 times diameter of the rod, and this total length is 6.22. So total length is total. So the length will be 6.22 plus 18 times diameter of the rod. Diameter is 10 millimeter, that means 0.01 meter. This comes to be 6.4 meter. Okay. So total number of bars we have found out to be, I think, 28. Length of one bar is 6.4. So total length of distribution reinforcement, total length of distribution reinforcement will be equal to 28 into 6.4 meter. Let us find out what is the result. This comes to be 179.2 meters. We need to convert this into weight. The rods which are used are 10 mm dia. For 10 mm dia, the length per kg is 0.62. Length per meter, weight per meter length is 0.62 kg per meter. That is the unit weight. So total weight will be 0.62 kg per meter multiplied by I think it was, total length was 179.2. so this comes to be 111 plus 110 kg. So we have found out the total amount of main reinforcement, the total amount of distribution reinforcement, and the total amount of R.C.C quantity. Okay, so in this way we calculate reinforcement members, R.C.C members. Next we'll be discussing about the calculation of quantities in an R.C.C beam.